Hey guys, this is Ganesh. Today I am going to discuss the topic OSI model or Open Systems Interconnection model. First of all, let's see why was OSI model created. In starting days of computer networking, vendors created proprietary networking models to support their own products. The biggest problem with these models was that they allowed communication only between the devices, those were manufactured by the same vendor. For example, a computer manufactured by the IBM was able to communicate only with the computer or networking device that was only manufactured by the IBM. So there will be no profit for vendors, right? So to break through this barrier, two major efforts were made. The first one was made by ISO and the second one was made by DoD. ISO, the International Organization for Standardization, created the OSI, Open Systems Interconnection model, and DoD, US Department of Defense, created the TCP or IP model. There are 7 layers in OSI model. They are application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. All these layers contain a package of protocols. Application layer. It is used to develop network-based applications. Network-based applications means computer applications which uses internet like Chrome, Firefox, Skype, etc. There are dozens of protocols in application layer. Some of the protocols are FTP, HTTP, HTTPS, SMTP, Telnet, FMTP, etc. Here, Chrome and Firefox uses the protocol HTTP and HTTPS for web surfing, while FTP protocol is used for file transfer, and email uses SMTP protocol. The layer responsibilities are including error handling and recovery, data flow over a network and full network flow. Presentation layer. Main responsibilities of this layer is to convert data from one format to another format. That means the data which is received from the application layer is in the form of characters and numbers. Presentation layer converts the data into machine understandable binary format. Before transmitting the bits to the next layer, it also decreases the number of bits. The decrease of bits is known as data compression. Data compression also reduces the amount of space used to store the original file. As the file size is reduced, it can be received by the receiver at very less time. Before sending the file, it also encrypts the data. So, encryption enhances the security of sensitive data. At sender sites, it encrypts the data, and at receive sites, it decrypts the data. Session layer. This layer is primarily responsible for setting up and managing communicative sessions, thereby enabling the sending and receiving of data, similar to a telephone call. Additionally, the session layer is also responsible for terminating sessions between software processes. There are many helpers in session layer. Common session layer helpers are often referred as APIs. Your web browser does the functions of all the three layers: application layer, presentation layer, session layer. Now let's discuss about transport layer. Transport layer. This layer responsibilities are segmentation, flow control, error control. Segmentation means the data which is received from the session layer is divided into segments. Each segment contains a source and destination port number and a sequence number. Port number helps to direct the segments to correct application, whereas sequence number is used to form exact data. Flow control. Flow control means, let's take an example. If a phone is connected to a server and the server can send the data at max of 100 Mbps and the phone can receive the data at max of 10 Mbps. If we are downloading a file from the server but the server starts sending the data at 50 Mbps, then our mobile phone with the help of transport layers can say to the server that to decrease the speed of data transmission. Error control. Error control means if any data doesn't reach the destination, then transport layer with the help of automatic repeat request schemes, it can get the lost data to the destination. Network layer. This layer responsibilities are logical addressing and path determination. In a network, for each and every computer, there will be separate IP address. The data which is received from the transport layer is in the form of segments. Network layer adds the source and destination IP address to the segments to form a packet. This is called logical addressing. Path determination. If there are many paths from the source to the destination, then the network layer selects the best path so that it can send the data from source to destination in very less time. Data link layer. This layer responsibilities of physical addressing and access the media, also known as framing. There are two types of addressing: logical addressing and physical addressing. Logical addressing is done in network layer, whereas physical addressing is done in data link layer. The data which is received from the network layer is in the form of packets. Data link layer adds the MAC addresses of source and destination to the packets to form frames. This is called physical addressing. Now let's discuss what is framing. Let's say there are two different hosts, one is desktop and another one is laptop. Both of them are connected to different networks. The desktop is connected to router R1 via Ethernet cable and the laptop is connected to R2 via wireless links. Both the router R1 and R2 are connected via satellite links. Here the desktop wants to send some data to the laptop. The desktop is source and the laptop is destination. The desktop network layer forms a frame by adding a head and tail to the packet and sends it to the router. The router receives the frame and decrypts it to a packet, and again the router R1 adds some header and tail to the packet to form a frame, and the router R1 sends the frame to the R2. The router R2 is receiving the frame and again it decrypts the frame to a packet and to a packet. The router R2 also adds some adder and tailer to form a frame and it sends to the laptop. Laptop receives the frame and it also decrypts the frame to a packet. The packet is sent to the network layer and the network layer uh, is also sends the data to application layer. After that, application layer receives the data and the data has been displayed on the laptop. This is known as framing. Physical layer. This layer responsibilities are conversion of bits to signal and signals to bit. It converts bits to signal at sender side and it converts signals to bits at receiver side. Till now, we have discussed transport layer, network layer, data link layer. The data which we have received from the session layer are divided into segments. Each segment carries a source and destination port number and sequence number. Port number helps to direct the segment to correct application, whereas sequence number helps to form the correct data. In transport layer, segments are formed. These segments are sent to network layer. The network layer adds the IP address of source and the destination IP address to the segments to form packet. This is called logical addressing, and these packets are sent to data link layer. Data link layer also adds the MAC address of source and the MAC address of destination to the packets to form frame. This is called physical addressing, and this frame is in the form of bits. These bits are converted into signals in physical layer, and these signals are sent through some medium. It is sent as electrical signal in case of copper cable or LAN cable. It is sent as light signal in case of optical fiber. It is sent as radio signal in case of air. At receiver side, the physical layer receives a signal and converts into bit. These bits are sent to data link layer as frames. As frames further decapsulates as the data go from higher layers. Finally, the data receives at application layer. Through the help of application layer protocols, the data will be displayed on the application of receiver end. Thank you. If you like the video, please like, share and subscribe.